So first they want us to sketch a picture. So I'm going to draw out my XY axes. Remember, this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. 4 pi over 3 is in quadrant 3, so my angle is going to be over here. And then it has a radius of 3. So if this is my point, this is going to be a circle with a radius of 3. So this is the point -x, -y. If I was on the unit circle, it would be cosine comma sine. But remember that we're not on the unit circle because the unit circle has a radius of 1. So my coordinate point is going to be r cosine theta, r sine theta. In this case, r is 3, cosine 3 sine. They're both going to be negative because I'm in quadrant 3. And my reference angle is going to be pi over 3. So -3 cosine of pi over 3, -3 sine of pi over 3. Cosine of pi over 3 is 1/2, and sine of pi over 3 is rad 3 over 2. So this becomes -3/2 is my x coordinate, and -3 rad 3 over 2 as my y coordinate. And this is going to be helpful for us today as we start to do converting between rectangular and polar coordinates. This is a rectangular coordinate because it is x comma y. So our target for today is at the end of 42 minutes, I can convert between rectangular coordinates and polar coordinates. Rectangular coordinates are x comma y, like we just discussed, and our polar coordinates are r comma theta. So here's a picture. I used quadrant 1 just to be simple. And you should already know how to convert between polar to rectangular because this is very similar to what we were just using. Converting from rectangular to polar is going to be a little bit different. So it's going to be r is going to be the square root of x squared plus y squared because on a circle, it's x squared plus y squared equals r squared. That's our equation for a circle. And then I'm looking for r, so I'm just going to square root both sides. And then this is my angle theta. So it can be found using opposite over adjacent, which is tangent. So tan of theta is equal to y over x, but I don't want tangent of theta. I want theta, so I'm going to find the inverse. So these are your formulas to memorize, and we're going to take a look at some examples. So we're going to start by converting each pair of polar coordinates to rectangular coordinates. So this means that r is equal to 2 and theta is equal to pi over 6. So x is equal to r cosine theta. X is going to be equal to 2 cosine pi over 6. Cosine of pi over 6 is rad 3 over 2. My 2's are going to cancel. So x equals rad 3. Then I'm going to repeat the process for y. Y is equal to r sine theta. So y is equal to 2 sine pi over 6. Sine of pi over 6 is 1/2. 2's cancel again, or rather divide out. So y is equal to 1. So this is the point, radical 3, comma 1. A quick check that I like to do for myself is that this is going to be in quadrant 1. It's a quadrant 1 angle, pi over 6. And this is xy, which is also quadrant 1. Let's take a look at example 2. So once again, r is 2 this time. Theta is 3 pi over 2. And if you wanted to sketch this one out, you might be able to do it that way. 3 pi over 2 is down here, and it has a radius of 2, but we'll do it the algebraic way. X is equal to r cosine theta. So x is equal to 2 cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. Anything times 0 is 0. Y is equal to r sine theta. So y is equal to 2 times sine of 3 pi over 2. Sine of 3 pi over 2 is -1. 2 times -1 is -2. So this is the rectangular point, 0, -2, which makes sense based on where I graphed it using my idea of polar. Now let's take a look going in the opposite direction. So this is the point -rad2, rad2. So I'm thinking to myself, this is -xy, which on a Cartesian plane or a rectangular coordinate, that is in quadrant 2. So when I'm done, my final answer, r comma theta, theta should be in quadrant 2 if I've done it correctly. So r is equal to the square root of x squared plus y squared. So in this case, r is equal to -rad2 squared plus rad2 squared. Remember that square root and a radical cancel each other out. And also remember that anytime you are squaring a negative, it becomes positive. So this is 2 plus 2, which gives us the square root of 4, which of course gives us 2. To find theta, it's inverse tangent of y over x. So this case, it's inverse tangent of rad2 over 2, radical 2 over negative radical 2. Anything divided by itself is 1. So this is inverse tangent of -1. So where is tangent equal to -1? Or remember that tangent is negative in quadrant 2 and quadrant 4. I have to be in quadrant 2 based on my original notes that I took when I started. My reference angle is pi over 4 or 45 degrees. So in quadrant 2, theta would be equal to 3 pi over 4. So my final answer, r comma theta, is 2 comma 3 pi over 4. We'll do one more example. So once again, I'm just thinking out loud. This is x comma y on the Cartesian plane or rectangular coordinates, which means it's quadrant 1. So when I'm done, hopefully my theta will be in quadrant 1. R is equal to the square root of x squared plus y squared. So r is equal to the square root of 3 rad 3 over 2 squared plus 3 over 2 squared. Doing some algebra. The y coordinate's probably easier for you. This is 9 over 4 because 3 squared is 9 and 2 squared is 4. The x coordinate, my denominator is definitely going to be 4. Your numerator, 3 rad 3 squared, is going to be 27. If you need to do that in a calculator, you can, or 3 squared is 9. Radical 3 squared is 3. And 9 times 3 gives us 27. So that's some scrap work if you need it. So this gives me radical 36 over 4, which is radical 9, which is 3 as my radius. Theta is equal to inverse tangent of y over x. So for this question, theta is going to be equal to inverse tangent of y, which is 3 over 2, over x, which is 3 rad 3 over 2. So you need to do some algebra over here. If you need to do it on the side and do keep, change, flip, that's fine. But this is going to be inverse tangent of 3 over 3 rad 3. Your 3's are going to divide out. So this becomes inverse tangent of 1 over rad 3. It's positive, so we're looking for a quadrant 1 angle. And my chart, you're looking for when is tangent equal to 1 over rad 3. For those of you that have the chart memorized, that's the same as rad 3 over 3. So you should know that theta is equal to pi over 6 or 30 degrees when tangent is rad 3 over 3. So r was 3, theta is pi over 6. So the polar coordinate point is 3 comma pi over 6. In the beginning of this question, we said that we wanted it to be a quadrant 1 angle because my Cartesian or rectangular point was positive x, positive y, which is quadrant 1. Pi over 6 is quadrant 1. So it is a reasonable solution.